Okay, we got. There we go. Okay. Oh, sorry. Wi-Fi. You know how it is. Uh, oh my gosh. Okay, so sorry about that, but we got a good connection now on the internet live stream. Looks like we open live and we got 4 people, 5 people already joined. All right, so the circuit is built. I've got the sensor circuit, the 3-phase H bridge with the low gate drivers and the high gate drivers, and that's all running over to my Arduino program here. I've got A2 and A3 on the analogs. Um, they're modified and running back to the sensors, as well as I believe pin 7 and 6. So that's basically how the sensor circuit works, and that keeps the motor in synchronous. Uh, but here is the whole reason why I want to share the video. If you guys notice on your cross points, you see that little line going up through there, and that little line coming back through here. That is the switching of the mode between the 3-phase, and that is the signal that you are getting from your pulse width modulated signal that you're getting from this Arduino. Now that, of course, everyone knows the high side gate drivers are going to run the positive side, and the low side gate drivers, which are just connected to ground, are going to drive the low side of these IRF 840 MOSFETs. Now I've got a little 1 amp 12 volt going in uh, right here, powering the high side, and of course, like I just said, the low side is just uh, got a 10K potentiometer between. It goes 1 to pin 3. That's our 10K right there. And then on the gate, also on pin 1, there's a 100 ohm resistor, and then that runs to your digital input or digital output on your Arduino. So now that I've explained the circuit a little bit, and this is for 3-phase permanent magnet motors or permanent field, 3-phase field magnet motors. And let me just show you what we've got here. Here's the third signal. Here's the second signal, and here's the first signal, and all 3 of them are going into the motor at the same time. But like I showed you at the very beginning, if I can get it to stop again, you'll notice, if you can actually see, here's the cross point right here, where this phase comes down, this phase goes up, and the other one is dropping off, giving you a sensor value. There we go. I think I got part of it there. Well, you can see how it comes up, and just like a sine wave, a normal sine wave. So we've got the circuit running. It actually runs really good. Everything's going great. Let me give you a better example of this this middle signal here. Let me back it back out a little bit. So a little, and we're very low hertz right now, and I can go even lower. 2000 hertz, 1000 hertz, all the way down to nothing almost. So the voltage drops off, the potential drops off when you lower your frequency. The higher the voltage and the higher the frequency, the better the circuit is, of course. So let me hit AO1 pin here back to ground, and I'm going to bring this frequency back up, and I'm going to zoom in. Well, let me stop right about there. And let's get a little bit closer. I'm going to hit this this button here, which just pulls, like I said, A1 or A2, 3, yeah, AO and A1. A1 is the speed increase or frequency increase, and I'm going to start pushing it now. And you'll notice we're 3,000 hertz, 4,000 hertz, 5,000 hertz, 6, 7, 8, 9. I'm holding it down. 10,000, 11, 12. Uh-oh. I glitched on the board over here. I'm clipping stuff, so sorry about that. It's not all in permanent yet. And no, frequency is getting too fast to read. I'll have to switch to here. Yeah, there we go. Notice that my oscilloscope that I made here can't keep up with it, so I'm gonna start hitting the button again. Go back up. 12, 13. It gets right at 16,000 hertz. So that's exactly what we need. My videos depict 396 volts at 14,893 hertz frequency. You get a 50% duty cycle, lower your energy consumption down, and once you get the high frequency going into the motor, I'm drawing it all back now. Now I'm gonna go ahead and unhook it. But once you get that going to your motor, and all I've got to do is power these MOSFETs here, and then it sends the signal right out of this wire right into the motor that I hook it up, and then we're using sound. No, the spikes in there is from the 3 different phases crossing into each other. One phase it'll be high and the other one will be low, and then that one will connect at the same time. One is also coming up through the middle, which is floating, and it gets a charge from both of them, which sends that charge through this sensor into the Arduino, and that's how we're keeping the motor synchronous. So if I've got this motor right here turning, and this is just a little bitty motor, over there is actual size of a motor. That's 12 inches. So we're going to use 700 watts to create a 45 horsepower motor using this technology right here. And it works, and there's already models being sold by another company. But if you have a few thousand extra dollars, then you can get rid of your electric bill forever. And it's a good deal, and it's Gerard Moore, the same guy that I've been friends with for a few years now. We've had the same technology. At one time, actually, we were in kind of like a competition to see who could get it out first, and of course, he's got a lot of funding and everything, so he was able to just purchase his controllers, and it has taken me almost 2 years to get the coding, and because the circuitry is no big deal. That's simple stuff. It's basically like a flip-flop with an extra bridge, and instead of running it off of itself, you've got the gates running the gate drivers, open the voltage, and running the gates on these high-powered 600 volt, I don't know, is it 15 amps on each one of these IRF 840s. So very high power. It's only going to consume 1 amp at about 396 volts is where I want it to be at. Does anybody out there have any questions? Let's see. Can you get rid of the spikes? No, that's actually, yeah, that's part of the sine wave crossing each other. You don't really want to get rid of those spikes because when you've got your zero voltage line here and you go negative 10 volts or positive 10 volts, okay, um, if you can modify your sine wave to where you go from a 0 volt line, go to negative 10 volts, and then back to 5 and go back to 10 again, that exactly the energy that is being modified in there works the same way the double slit experiment works. So when you go down to negative 10 and come back up to negative 5, you're actually gaining another 2.5 volts here and 2.5 volts here from it, the electrons splitting themselves and going in separate directions wirelessly. So when you go back to 10, it's it's an amplification, and Nikola Tesla knew how to do it as well. And I don't know if everyone out there knows that it's in these little ESCs, these little electronic speed controllers, but the technology is inside those as well. And I could actually spin this, and well, I'll have to adjust it back a little bit. There we go. Get a little bit of a frequency out of it. And if I could catch it fast enough, you'll see the signal, the bottom line signal, the top line signal, and everything else. You could actually be able to see the signal from here because it's feeding back into it, and which that actually goes to the sensor here, and the sensor goes to the back to the Arduino. So the group, it's got a bunch of coders in it and stuff, and I'm fixing to task one of them, hopefully, to get a my touch screen here for my Atmega, and I know I've got to use pin 11 instead of pin 9, but it's really, that's no big deal. I would just like this large touch screen that I've had. I've ran some tests on. The thing works good. It's hooked up, and I'm ready to put this to use so that I can see the voltage, PWM speed, and everything, and then have my AO and A1 pin down here on some push buttons to increase the speed on here. So hopefully we can get that done and set up. I'd really like to see that going. That way you can walk up to your machine and turn it on, and then you've got increase the speed, and when you get to 3600 RPMs, you know, then you just stop it right there and you're done. You don't have to program it again or anything like that. The PWM starts out at let's see here, start duty cycles 100, PWM's 255, which I believe that's in digital delay. But yeah, the coding for it's right here. It's not too extremely hard, and it's all open sourced, so it was all free. And if I can, let me go back up to the top here. We've got blueprints, diagrams, the schematics, basically everything. Now for the larger motor, this is for a small motor, but now for a larger motor, I changed some of my resistor values, 3 of these. I changed the MOSFETs on here, all 6 of them. I beefed them up really good. And I'm not using the IR2104Ss, these high side and low side gate drivers here. I actually just built my own for the gates right here and here, all 6 gates, which is what I was saying earlier, is I've just built my gate driver onto here, and it was a problem with shipping. No big deal really, but stuff happens, and I still don't have the MOSFETs, the IR2104Ss, gate drivers. Sorry, not MOSFETs. That's funny. And I didn't use the 06 and 03s. I used the IRF 840s. So they're a whole lot beefier. This is complete instructions on how to build all of this. Now you're going to have to, of course, go to my YouTube channel to find the rest of it. But here's the link to this. It says simpleprojects.com/Arduino-sensor BLDC motor controller ESC. So that's where you can go to find this circuit diagram here and these instructions. And like I said, I just took what was here and modified it because this is all open source. Let's see, I will show you where it says open source. Well, I can't find it here. Let me click on the source code and scroll down to, yeah. Oh, really? This is a free. Alright. This is a free software without any warranty, which is just like most Arduino projects. You know, someone writes the code for it. If you got a problem with the code, then, you know, sorry, you need to learn how to program your own code, which is what I've been trying to teach myself how to do. But this is all the code right here, and you can find it on this guy's on this website with this guy's project on here. And I mean, it works. We've got a he used it on a 12-volt system, which is why I beefed up the MOSFETs. But if I can get his name here, I'll give him some credit for this. Simple Projects, and I don't see his name, and I don't remember seeing his name either. Let me go back to his video here, and it took me a long time to find this.
Yeah.
Sensorless, brushless, BLDC motor controller. Hopefully there's no ads on here, so okay, good. Yeah. Well, if my computer will work. There we go. Alright. So, Simple Projects. Yep, 1.4 thousand subscribers. So go check this guy out. I subscribed to his channel, at least, you know, to thank him for the video that he made here. Like I said, it's a very simple. He's got a printed, or no, it's not printed, never mind. But it's the, yep, it's the same thing that I'm doing here. Like I said, I'm just jacking the voltage up and getting rid of that resistance. So the higher the voltage, the less resistance. The higher the frequency, the less current consumption. So that's how that works. And people that, scientists, physicists, people like that, they will know what I'm talking about when I say that. Or, well, most people that, let's see here, let me check that out. No, that's for my inverter. 9, 8, yeah, that's a variable frequency inverter there. Let's see, I did a simple one. This was someone else's. I just changed it a little bit. So I initialized a couple of pins and added the digital delay.
So it's a very simple circuit, but that is an oscillator, and I can take a battery and hook up to a H-bridge, and I can have alternating current come off of that, and then I can run this H-bridge from there. So one battery to power the whole thing, and that one battery can be recharged using just a regular battery charger. Probably be plenty enough current coming through there. You're looking at 1,000 or 2,000 watts, depending on how big of a system you build in energy consumption. But like I said, you'll be able to turn 20,000 to 50,000 watt PTO or self-excited generator head. Well, I hope you guys enjoyed the video. I'm pretty happy to have everything done and set up and finished. Got everything running now, and I'm excited. So with that, I'm going to go ahead and end this video, and I love you guys, and I've got some other videos to upload to show exactly how to build all of this. If you have problems building stuff, or you're a beginner, then go on over to my channel, because I've got 140 videos or 140 something videos on there.
41.
You'll be able to find it out. So, alright, well, don't forget to hit the like button and share this. And hey man, thanks Craig, I sure appreciate it, man. Thanks Ray. Yeah, hey, no problem Omar. Skip, brother, you know I love you. I'll talk to you soon, and we're gonna move forward with this. So anybody want to buy me a another 10,000 watt generator head? That'd be great. Well, I got two from Gerard Morian, but I used one for 2 years, and then, well, the other one went out. It was just a fluke. Literally, a piece of plastic went in there and tore up the stator coil. So, that kind of sucked. But alright, well, I love you guys. Y'all have a great day, and have a great rest of your weekend. And I just wanted to show you a little bit of progress. So, have a great one.